Hello everyone. Now let's talk about the last part of this chapter, which is about production bottlenecks and managing the bottlenecks. So what is a bottleneck or production bottleneck? Sometimes we call it a constraint. So it's a point in the manufacturing process where the demand for the company's product exceeds the ability to produce the product. So simply, we have more demand than what we can produce. So the theory of constraints is a manufacturing strategy that focuses on reducing the influence of bottlenecks on production processes. So when a company has a production bottleneck, it should attempt to maximize its profits by using the unit contribution margin of each product per production bottleneck constraint. So we'll understand that once we see an example. So we have this company called Craft Tool. It makes three products, product A and B and C. And all three products are processed through heat treatment, which hardens the steel. Okay, so the heat treatment is needed to harden the steel used in producing these products. The heat treatment process is operating at full capacity and is a production bottleneck. So the product unit contribution margin and the number of hours of heat treatment used by each type of tool are as follows. So we have for product A, product B, and product C. Here you see the unit selling price for product A 130, for B is 140, and for C is 160. So you can see that the most expensive product or the highest selling price for these three products is product C. The variable cost is the same for all three products, which is $40. The contribution margin is actually the highest for product C, which is $120, and it's lowest for product A, which is $90. The heat treatment hours per unit, which is considered to be the bottleneck for this production, it's only 1 hour for product A, 4 hours for product B, but it's 8 hours for product C. So, as I've just mentioned, product C appears to be the most profitable product because its unit's contribution margin of $120 is the highest or is the greatest. However, the unit contribution margin can be misleading in a production bottleneck operation. Why? Because we have to keep in mind this kind of bottleneck that these three products are facing. So in a production bottleneck operation, the best measure of profitability is the unit contribution margin per bottleneck constraint. And we'll see how we calculate that. So the bottleneck constraint is heat treatment process hours. Therefore, the unit contribution margin per bottleneck constraint is expressed as follows. We get the unit contribution margin and we divide it by the heat treatment hours per unit. So the unit contribution per bottleneck hour for each of the products produced by Craft Tool would be computed as follows. So for product A, it's $90 divided by 1 hour, which is the heat treatment hours per unit, and that's $90 per hour. For product B, it's 100 divided by 4 hours, and that's $25 per hour. And for product C, it's $120 divided by 8 hours, and that's $15 per hour. So now I think we can tell that product E is the most profitable product per bottleneck hour and is the one that should be emphasized in the market. There's an issue with pricing bottleneck products. In the example that we just talked about, product A is the most profitable product per bottleneck hour. As a result, if one product is to be produced, it should be product A. But what about product B and C? So even though product A is the most profitable, Craft Tools customers may also want product B and C, and we need to satisfy the customer's demand. So in these situations, product B and C should be comparably priced to product A, or the production process for the other products should be adjusted so that they consume less of the bottleneck. Alternatively, the manufacturing process for product C could be adjusted to reduce its consumption of the bottleneck. Again, these are all suggestions, but if you have the choice to produce A, B, and C, of course, product A is the most profitable for this company. Let's try another knowledge check activity. So what is the best measure of profitability in a production bottleneck operation? Is it the unit contribution margin per bottleneck constraint? I think sounds reasonable. This is what we've been talking about. Fixed cost per unit bottleneck constraint. I don't think we ever talked about that. Theory of constraints, I think that's funny. Production bottleneck constraint. So the right answer is A. All right, so it's the unit contribution margin per bottleneck constraint. So in a production bottleneck operation, the best measure of profitability is the unit contribution margin per bottleneck constraint. Right, the last part of this chapter, we want to do some kind of analysis for decision making, and we're going to be talking about the yield pricing in service businesses. So far we've been talking about manufacturing and seeing the variable cost, fixed cost, and the differential analysis. Now let's try to see how this is different in a service business. So service businesses compared to manufacturing or retail businesses often have larger fixed costs because they require significant property, plant, and equipment to deliver the service, and therefore many service companies have a low variable cost per unit. Thinking about hotels, airlines, hospitals, they have a lot of investment in property, plant, and equipment. And the variable cost compared to their property, plant, and equipment is very small. So high fixed cost services businesses often charge different prices to different customers depending upon their utilization of fixed capacity. And this is why, I think a perfect example would be airlines. They charge different prices for different customers depending on when they are making their ticket or buying their ticket. So, and I think this is part of deciding on how they utilize their fixed capacity. So during periods when the demand on fixed capacity is high, prices are higher. When the demand for fixed capacity is low, prices are lower. So high capacity cost service businesses will offer attractive prices to customers who reserve a portion of fixed capacity early and will penalize customers for reserving a portion of fixed capacity late, such as airline tickets. And sometimes, if the fixed capacity is already covered and they still have some extra capacity, for last minute customers, sometimes they offer them a discount. And we'll see an example for that. So yield pricing is accepting businesses at a special price differential analysis. So let's see an example for a company called Alpine Airlines. They have the following, they have the following fixed and variable cost for a flight. So these are their fixed costs per flight, their plane depreciation, the crew salaries, the fuel, ground salaries, airport fees. And then for the variable cost per passengers, they have $12 per passenger for fuel. Again, because the more passengers you have, the more fuel they would need, ground salaries, and passenger services. So you see here, variable cost per passenger in total is $35, but the fixed cost per flight is $18,400. The plane has a capacity of 200 seats, and 170 have been sold already at an average ticket price of $150. Therefore, the unit contribution margin and break-even seats will be calculated as follows. So we get the ticket price minus the variable cost per passenger. So we have here the ticket price, $150, minus the variable cost per passenger, $35. That's $115, and that's the contribution margin per passenger. Now let's see a break-even seats for flights. We get the total fixed cost per flight, which is $18,400, and we divide it by the contribution margin per passenger that we just calculated. So in other words, how many passengers or seats we need to cover the fixed cost per flight after covering our variable cost. That's the whole idea here. So we're taking the $18,400 divided by $115, and it turns out that once we sell 160 seats, then our fixed costs per flight are covered. So each flight is earning a profit since the actual seats sold, $170, exceed the break-even, not dollars, I mean 170 seats exceed the break-even number of seats, which is 160. Remember, the capacity of the flight is 200. So to attract customers to its 30 unsold seats, Alpine offers a 50% discounted ticket for standby passengers. So assuming 10 standby passengers purchase the discounted ticket, Alpine will have additional income based on the contribution margin of these seats. And this is how it's calculated. So they normally sell it for $150, they sold it for 50% of that, that's $75. Remember, the variable cost is $35, so now they have $40 contribution margin per standby passenger, these additional passengers. And then we have 10 of these passengers, they they got our tickets, so we have an extra income of $400. Remember, that's extra income, so there's nothing that hurts here. All right, so I think that's everything for chapter 25. I hope you find this useful. Please study hard, and I wish you all the best.